Today, we're going to get our hands dirty, so to speak, with the hardware that makes VxRail one of the most powerful hyperconverged systems out there. We're going to deconstruct it piece by piece and really see what makes this thing tech.
So let's just start with a simple question. What if you could take everything that makes up a traditional data center, the servers, the big storage arrays, all the networking switches, and just shrink it all down into a single, easy-to-manage box? Well, that's really the big idea behind the tech we're about to break down.
And the magic that makes this happen, it's a concept called hyperconverged infrastructure, or HCI for short. It's all about smashing together compute, storage, and networking into one unified system. And that tight integration, that's the secret sauce that makes everything so simple and so incredibly powerful. All right, let's dive into the hardware itself. To really get a handle on VxRail, you have to start with its most basic, most fundamental piece, the node. You can think of it as the Lego brick of the whole system. So what is a node really? Well, simply put, it's a powerful server. But I think a better way to think about it is as the workhorse of the system. Each one of these nodes brings its own CPU power, its own memory, and its own storage to the party. And the cool part is, as you add more nodes, the whole system just gets more powerful and more resilient.
So what's actually packed inside one of these workhorses? Well, it really boils down to four main things. You've got your compute, that's the brain, the CPU. Then you have the memory, or RAM, for all the active stuff. Of course, you have storage for all your data. And then, for more specialized jobs like AI or virtual desktops, you can even add a powerful graphics card, a GPU. Let's start with compute. VxRail nodes are running multi-core Intel Xeon CPUs. Now, the crucial thing to understand here is that these aren't just any old processors. They are specifically built for the crazy demands of virtualization. We're talking about chips designed to run dozens, sometimes even hundreds of virtual machines at the same time without breaking a sweat. And of course, to run all those virtual machines, you need an absolutely massive amount of memory. In some of the higher-end nodes, we're talking up to 4.5 terabytes of RAM. That's a huge amount, and it's what lets you run those really memory-hungry applications like giant databases or SAP HANA without hitting any performance bottlenecks. Now for storage. And this is where things get really clever. VxRail has this brilliant two-layer system. Think of it like having a workbench and a warehouse. The cache layer is your workbench. It's made of super-fast NVMe or SSD drives, and it holds all the data you're actively working on right now. Then the capacity layer is your warehouse. It's where you store everything else. This setup gives you the best of both worlds: insane speed when you need it, and huge capacity for the long haul. Okay, so we've got these powerful nodes, just packed with compute, memory, and storage. But they're kind of useless if they can't talk to each other, right? That brings us to the system's nervous system, the networking and management pieces that connect everything and make it work as one. Now, that communication between nodes has to be incredibly fast. This is for things like VMware vSAN, which is constantly moving data around the cluster. So to support that, each node is loaded up with multiple high-speed network ports. We're talking 10, 25, or on the new stuff, even 100 gigabits per second. That massive bandwidth is absolutely critical for things like replicating data and balancing workloads, which keeps the whole cluster running smoothly. But what about managing the physical hardware itself? Well, that's where Dell's iDRAC comes in. The best way to think about it is as a built-in remote control for each and every node. And here's the really important part. It works totally separate from the main operating system. So even if a node is powered off or the software has crashed, iDRAC is your lifeline. You can still get in and see what's wrong. And using it is actually way simpler than it sounds. You just find its special IP address, pop that into a web browser, and boom, you've got a whole dashboard showing you the health of every single component inside that node. From the fans to the power supplies to the memory, it's all right there. It just makes a really complex job super accessible. So all this high-performance gear, it generates a lot of heat, and it needs a constant, rock-solid supply of power. This brings us to what I like to call the unsung heroes of any data center, the life support systems for power and cooling. If there's one word you need to remember in this section, it's redundancy. The entire design philosophy is built around eliminating any single point of failure. It just means that if one part breaks, there's another one already running, ready to take over instantly, so your applications never go down. So how does VRail actually do this? Well, for starters, every node has at least 2 power supplies. If one fails, the other one just takes the full load, no problem. And the best part? They're hot swappable. That means you can literally pull out a dead power supply and plug in a new one while the server is still running. Zero downtime. On top of that, you've got rows of powerful redundant fans managing the airflow to keep everything nice and cool. And all that cooling is just so important because every piece of enterprise hardware has a happy place, an optimal range where it likes to operate. You want to keep the room temperature somewhere between 18 and 27 degrees Celsius and the humidity between 40 and 60%. Sticking to this is just vital for making sure your hardware lives a long and healthy life. Okay, so we've looked at all the individual pieces, the nodes, the networking, the power, and cooling. Now let's put it all together. Let's see how these building blocks are combined into different VxRail models that are each built for a specific job. This chart gives you a pretty good bird's eye view. The E-Series is your all-around general-purpose workhorse. The P-Series is beefed up for performance-heavy stuff like databases. The V-Series is the one packed with GPUs, perfect for AI, machine learning, and VDI. Then you've got the S-Series, which is all about massive storage capacity for backups or data lakes. And finally, the D-Series is this cool, ruggedized version that's built to survive in tough environments. So, how do you pick the right one? Well, it's all about matching the hardware to your workload. Just running a bunch of standard virtual machines, the E-Series is probably your best bet. Powering a critical database that needs every ounce of performance, you'll want to look at the P-Series. Training an AI model, the V-Series is the one for you. See, it's really all about picking the right tool for the right job. And that really brings us right back to where we started. Every single thing we talked about, the CPUs, the RAM, the network cards, the power supplies, they are all individual building blocks. But the magic of VxRail is how they're all engineered and pre-tested to work together perfectly as one single cohesive system. So let's boil it all down. What are the key things you should walk away with? First, the node is your fundamental building block. You just add more as you need to grow. Second, redundancy isn't just a nice feature, it's absolutely essential for keeping things online. Third, tools like iDRAC are your best friend. They make managing everything so much easier. And finally, picking the right model for your specific job is totally critical to your success. So there you have it. We've pulled apart the hardware and laid out all the pieces on the table. We've shown you the fundamental building blocks of a modern data center. Now the only question left is, what are you going to build with them?